I did a thing! If you remember the video I made a year ago where I showed off a very early concept of exporting Unity assets into a PlayStation 1 scene, well, then you might be interested in what I've got to show you now. We've got Lua scripting, sound, animations, cutscenes, character animations, fog, a full UI system, loading screens, custom fonts, collisions, trigger volumes, interactables, navigation meshes, documentation. For the love of God, read the documentation before asking questions! Building burnable ISOs, deploying into an emulator, even deploying to a real console without needing to burn a disk. All within Unity. You don't ever have to see the actual C++ code it runs on. You just click a button and it runs wherever you want. Yeah, a lot has happened, so let me show you. But before we get into what PSX Splash actually does, I need to catch some of you up. Because if you haven't been watching my videos, which is totally fine, it's okay, I don't hold it against you, maybe, you might not know what we are actually working with here. You knowledgeable people, skip to here. It's lesson time. The PlayStation has a 33 MHz CPU. 33 MHz. Your phone's Bluetooth chip is faster than that. This random image from my phone is bigger than the amount of RAM the PSX has. And here's the fun part. There is no floating point unit, no FPU, meaning the CPU cannot do decimal math at all. So you have to use something called fixed point arithmetic, which is basically, you take an integer and you pretend really hard that the last 12 bits are the decimal part. So instead of 1.5, you store 6144, which is 1.5 times 4096. And there's also no Z buffer. Modern GPUs use a depth buffer to figure out which polygon is in front of which. The PlayStation doesn't have that. Instead, it uses something called ordering tables, which is basically a big linked list where you sort every polygon by distance. You see, you have this array of like 16,000 slots, each representing a depth, and you insert your triangles into the right slot and the GPU just draws them back to front. But while Sony was developing the reason for our depressions, one hardware developer was like, you see, we don't want the population of game developers to go down due to reasons I can't say on YouTube. So the PlayStation has a coprocessor called the GTE, the Geometry Transformation Engine, which is basically a high-speed matrix calculator bolted directly onto the CPU. You feed it vertices and it spits out screen coordinates. It does rotation, scaling, perspective projection. Without it, 3D on this hardware will be borderline impossible. And then there's the VRAM. The PlayStation has a 1024 by 512 pixel image. And that's it. That's your VRAM. Your 2 frame buffers live here. Your textures live here. Your color lookup tables live here. Your fonts live here. Your UI images live here. Everything. Everything. One image. It's basically a puzzle and not the fun kind. And for audio, there's the SPU, the sound processing unit, with its amazing 512 kilobytes of SPU RAM. You can't fit all that much into that. So this is the part where I tell you why PSX Splash exists. The biggest problem with making PlayStation 1 games has always been assets. You need to take all your textures, models, worlds, sounds, and everything. Us, as the PlayStation 1 community, has not been able to settle on one thing. And here I am making another one. Usually this is done by writing custom converters, and nobody wants to deal with that. It's a nightmare. You have to pack textures into VRAM by hand and everything. Everyone hates doing that. And I keep doing it over and over again. Bandwidth from the edit here, just to prevent the most awful question ever, and so people don't ask me. Godot is not happening yet. It's using Unity because I know Unity and I don't know Godot. Once it's polished, maybe we can do Godot or a custom editor or something like that. But right now the goal is make it exist. Please, please, please do not ask about Godot. So instead, PSX Splash lets you do everything from Unity. This is the PSX object exporter. You slap it on any mesh and it tells the exporter how to handle that object. What texture bit to use, where it has collision, where it should use baked lighting or flat colors. This is PSX Player. It handles your player controller, walk speed, sprint speed, gravity, and it's got this whole built-in nav mesh system. You click on build nav regions, it uses .recast underneath, and you get a proper convex polygon navigation mesh. The player walks on it. Slopes, stairs, multi-level floors, the whole thing. And then there's the control panel. This is mission control. From here you manage your scenes, set your build target, emulator, real hardware via USB, or a disk image. Check your memory usage and do your builds. You see this memory report? That's your 2 megabytes. Every vertex, every texture, every Lua script, every audio clip. It all has to fit. And this tells you exactly where you stand. Although currently it's horribly outdated and at 60% you're already full, but hush please. When you hit build, here's what happens behind the scenes. Your textures get quantized down to indexed color, and this is actually a pretty involved process. It runs k-means clustering to find optimal palettes, uses a KD tree for fast color lookup, then applies Floyd-Steinberg dithering so you don't get harsh banding. The result gets packed into VRAM, and packing textures into a 1024 by 512 image alongside 2 frame buffers and all your CLUDs, that's essentially a modified version of the classic knapsack problem. Your models get triangulated and exported into a custom binary format called a splash pack. All your Lua scripts get precompiled into bytecode so the PlayStation doesn't have to waste time parsing them. A bounding volume hierarchy gets built so the renderer can do first-time culling, and audio gets converted to SPU ADPCM. You never see any of this, you just press a button. So, one of the most important things about PSX Splash is that you write your game logic in Lua. Not C, not C++, Lua, a real scripting language running on a real PlayStation 1. And this isn't just some stripped down version. You've got a proper event system. Your objects have lifecycle callbacks. OnCreate fires when the scene loads. OnUpdate gets called every frame with a delta time. OnCollide with player does, yeah, just the thing that it says it does. OnInteract fires when the player interacts with something, and you've got OnButton press and OnButton release for direct controller input. You've also got OnUpdate, it's for debugging purposes. Don't use it, the PlayStation can't handle that. If you use it, I will be waiting for you at night in your closet. You can reference other objects with entity.find, move the camera with camera.setPosition, play sounds with audio.play, toggle UI elements, start cutscene, check input with input.isPressed. It's a full API. Okay, so this is probably the feature I'm most proud of. You can make cutscenes, proper cutscenes with camera movement, object animations, UI transitions, and even controller rumble. You create a PSX cutscene clip, that's this thing right here, and inside you can have tracks like rumble small motor, rumble large motor, audio events, skinned animation events, more on that later. Camera position, just all the stuff. There's like 13 tracks, I think. Each keyframe has an interpolation mode, so you can select linear, step, ease in, ease out, and ease in, ease out. The easing is cubic, and the whole system uses subframe interpolation, so it looks smooth even when the PlayStation is running at 30 or even inconsistent frame rates. To play a cutscene from Lua, you just yeah, like that. When the cutscene runs, it disables player controls, plays the cutscene, and when the cutscene completes, this callback gets called, which re-enables the player controls. And for character animation specifically, you know, like a character walking, waving, attacking, that's the skinned mesh system, up to 64 bones per mesh, pre-baked at whatever FPS you want. You export it from Unity with the PSX skinned object exporter, and from Lua you just call skinnedanim.play, and it handles bone matrix composition, interpolation, the whole thing. I absolutely love that demo. But let's talk about how PSX Splash renders stuff, because this is where stuff actually gets intense. The renderer does double buffered 300 by 240 output. Every frame it goes through all visible geometry, runs the vertices through the GTE for projection, does backface culling, checks screen bounds, inserts everything into the ordering table by depth, and fires it off to the GPU. But the interesting part is what happens before, because you can't just render everything. Remember, 33 MHz, so there's an entire culling pipeline. For exterior scenes, there's a bounding volume hierarchy. It's a tree of bounding boxes and the renderer walks it every frame, testing each node against the camera first time. If a node is outside your view, the entire subtree gets skipped. You only process triangles you can actually see. For interior scenes, think hallways, rooms, buildings, there's a room and portal system. You define rooms, you define portals between them, and the renderer only draws rooms that are visible through portal connections from wherever the camera is. So if you are in room A and room C is behind two walls and a closed door, it doesn't get rendered at all. And then there's fog. This is per vertex fog with configurable density and color. For textured triangles, it actually does a two-pass approach, one for the fog overlay and one for the attenuated texture. This approach is known as Silent Hill Fog, since, it used it. And there's an amazing video by Elias which helped me actually implement this, so thank you. Is it expensive? Yeah. Does it look good? Most of the time. Does it look nice? Heck yeah. And honestly, half the reason it exists is to hide pop-in, which is what every PS1 game used it for anyway. So we are being historically accurate. You're welcome. Damn it, I have to get faster. YouTube users' attention span. Okay, so navigation. Splash Edit generates a nav mesh using .recast, which is a C# port of recast navigation. The mesh is made of convex regions connected by portals. Each region has a floor plane fit to it, so the player follows the terrain smoothly on slopes and ramps. There are 3 presets: indoor, terrain, multi-level. Pick the one which mostly fits your use case, or, change all these weird numbers. Collisions is axis-aligned bounding boxes. There's a spatial grid for broad face, so checking 64 colliders doesn't kill the CPU. You can mark objects static or dynamic, and there are trigger boxes that fire on-trigger enter and on-trigger exit events to your Lua scripts. And then interactables. You put a PSX interactable component on an object, set a radius, pick a button, and when the player walks close enough and presses that button, your Lua on interact fires. You can even set it to auto-show a UI prompt when you are in range. One shot or repeatable with a cooldown. Done. So, a month ago, I put up a video and I basically begged you. I said, please, 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 pretty please, go use PSX Splash. Make something with it. Break it. Tell me what works, what doesn't. And you guys really did.
Heitäpä vähän löylyä. Heitäpä vähän löylyä.
from you. It won't be a stylish marriage. I can't afford a carriage. But you look sweet upon the seat of a bicycle built for two.
You see, seeing my work being used to create something this beautiful, I can't even believe it. I feel like I have left my mark. So thank you to everyone who has jumped in. It's amazing. Thank you. So I want to be real with you for a bit, because you people deserve it. The last year it's been a lot. What started as a follow-up to a school thesis project has grown into something way bigger than me. PSX Splash is 2 code bases, a C++ code base and a C# code base, and it has grown way over my head. I've been answering questions, fixing bugs, helping people get set up, and I love doing that. I love helping you people create beautiful things with this, but due to time zones, I haven't been sleeping all that much. I've had to cut back on actual paid work, which is, you know, not the best financial strategy. So I'm gonna do something I hate to do, which is ask for stuff. If PSX Splash is something you love to see and something you want to see grow, there are a couple of ways you can help. First of all, and this is the most important one, if you are a developer who knows C++ or C#, Unity, and you love toying around with stuff like this and you just want to get deep down into the bare bones stuff, I need your help. There are only 2 developers right now, which is me and Latch. And Latch has jumped on only recently. I'm struggling to keep up. If you can help me finish this and make it a good, amazing thing to make PlayStation 1 games in, that would be amazing. Second, I recently redid my YouTube memberships all over again, and I'm not trying to guilt anyone into doing anything. If you're a student, if you're broke, or if you just don't want to, that's okay. Watch the videos for free. That's what they are for. But if you're in a position where a couple bucks a month is nothing to you, and you want to directly keep this project alive and let me spend more time on it, instead of, you know, doing stuff that actually pays rent, then the option is there. And honestly, even just using PSX Splash, filing bug reports, sharing the video, everyone who tries it hands-on and gives me feedback, you people are amazing. Thank you very much. So yeah, that's PSX Splash. A year ago it was a concept, now it's a fully working game engine in which you can make actual games. In Unity, on a console from 1994. And trust me, we are not done. Huge thanks to all the people who have been with me on this incredible journey. Thanks to Nicholas Noble again, who's been serving as a hotline to my gaps in PlayStation knowledge, even offering his army of AIs for hard-to-tackle problems. But most of all, I would love to thank Latch, who just appeared out of nowhere on the Discord server and started creating pull requests, fixing stuff I left unfixed behind, and implementing new features of his own. Latch, thank you. Without you, I would be like... If you want to give PSX Splash a try, all the stuff is in the description down below. The documentation, the website, the Discord server where you will get support. Please, please, please consider subscribing and liking. That's the easiest way to support this, and I will see you next time where we make some cool stuff with this game engine. Thank you. Bye. That was awkward. That was way too awkward. I don't care. I'll leave it in.